In case 3 of integration by partial fraction, in the denominator, you will see irreducible quadratic factors. Irreducible means cannot be factored, and those factors, they are not repeated. So in this example, x minus 1 is a linear factor, and then the x squared plus 9 is quadratic. Second power means quadratic. Quadratic, the graph is a parabola. And I have to remind you that a squared plus b squared cannot be factored. You study this in elementary algebra. Okay, how do we assign the letters when for irreducible quadratic factors? So here is how. So we have 10 divided by x minus 1 times x squared plus 9. So the x minus 1 is linear, so we use one letter for that, x minus 1. For the irreducible and quadratic, we use two letters. So let's draw this first, x squared plus 9. Two letters, how do we represent? Just b plus c? No, we do b x plus c. This is something that you have to memorize. In this case, for each irreducible quadratic factors, you have to use two letters. Okay, and then the next step, we will do the common denominator. So the common denominator for a we have x minus 1, we need a x squared plus 9. So a, we need a x squared minus plus 9. And then for bx plus c, we already have the square, so we need x minus 1. This one you can try using convenient value, but that is not going to help too much. So let's try it. If x is equals to 1, this one right here, x is equals to 1, then on the other side, we have 10 equals to a times 1 plus 9, so which is 10, right? A times 10, and then we don't have b and c, so we know we solve for a, so a is equals to 1, but we still have b and c. The convenient value, you cannot try any other convenient value because x squared plus 9 is never equal to 0. So the convenient value trick ends right over here. So since the convenient value is not going to work anymore, then you have to open this up. So let's fully open up. So 10 is equals to distribution ax squared plus 9a, and then plus bx squared minus bx plus cx minus c. And then you group all the squares together. So the square, so let's use the color to separate them. So the square, right? And then the first power is right here. And then we have the constant. The constant is the 9a and the minus c. Okay, let's group them. So we have ax plus bx squared. So we have ax squared plus bx squared. And then we have minus bx plus cx. And then plus 9a minus c. And then let's do a little factor. Let's save some space on the left. So we factor out the square. We have a plus b, and then x squared. And then we have minus b plus c, factor out the x, and then the 9a minus c. So this is a 10. We don't have square, we don't have x power. We can make them by doing this. 0x squared plus 0x plus 10. All right, and then you equate the coefficient. 0 matches to a plus b, and then another 0 matches to minus b plus c, and then the 10 matches to the 9a minus c. All right, let's do the system. So this step is called equating the coefficient. So equating the coefficient, which color should I use? Let's use red. So equating coefficient, we have a plus b equals to 0, a plus b equals to 0, and then minus b plus c equals to 0, and then 9a minus c is equals to 10. Don't underestimate the convenient value we just did, a equals to 1, because that will simplify the system immediately. So this, we have a1 plus b equals to 0. 9 minus c equals to 10, right? So that tells me b is equals to -1. I got B. And this tells me C is equals to 9 minus 10, which is also negative 1. So the system can be solved almost immediately. So don't underestimate those little convenient values. All right, now we got A, B, and C, and then we plug it in, and then we integrate. So go back to purple. So plug it into where? Plug it into here. Look at the yellow dots. The very beginning. All right, so A is a 1, so we have integral 1 divided by x minus 1 dx, and then plus bx plus c, so negative x minus 1 divided by x squared plus 9 dx. All right, the first one is just ln absolute value x minus 1, right? So the second one, you can divide that into two fractions. The first one is negative x divided by x squared plus 9, that is a u substitution, and then negative 1 divided by x squared plus 9, that is our inverse tangent. So this one u substitution, u equals to x squared plus 9 du equals to 2x dx. So the x will be cancelled, right? So you have negative 1/2. The x will be cancelled, and then you have 1 over u. The 1 over u is just an ln, right? You have integral just 1 over u. So that will be an ln. So we have ln x squared plus 9, that is always positive, so it is not necessary to use parentheses. Okay, what if you use absolute value? When you do homework online, the system will count that as a mistake. So be very careful. This absolute value is not necessary. If you use an absolute value, you lose points. And then ln x minus 1. And then the last one, I have to remind you a formula. That is the integral of 1 divided by x squared plus a squared dx. That is equals to 1 over a, and then inverse tangent, which is arctangent, x minus a, and then plus c. So here, a is equals to 3, because 3 squared is equals to 9. And then the last one, you have minus, right? So this is a minus 1 over 3, and then inverse tangent, x divided by 3, and then you plus c. So that is the end of this problem. If you think I gave you the best example and my explanation is clear, let me know in the comment below. Please like the video and share the video for me. I really want more people watch my video. Subscribe to my channel if you are new to the channel this time. Appreciate for your help and support to the channel. See you all in the next one. Signing out for now.